trying not to take too long on these because it's already going long here. But all right, now we're going to use Trig to estimate measurements. Okay, this is where it's going to get a little trickier. All right, so here's our situation. Fitness trainer sets the incline on a treadmill to 7 degrees. There's our 7 degrees. The walking surface is 5 feet long. That's up here. How many inches did the trainer raise the end? So that's the y. Okay, and so what we know, the angle that we know is the 7. So this is what it's going to be based on. Okay, so let's see what all these other sides are based on this degree right here. Well, this angle here, what's the hypotenuse? Here's the 90, look straight across. This is the hypotenuse. What side is the y? Well, y is way, way, way over here. This is the opposite side. And then the side here, this is the adjacent side. We don't know the adjacent side, but the adjacent is the one right next to it. So what we have to do is we have to figure what ratio can I use that tells me opposite and hypotenuse. What's the O and the H? Okay, so think back to SOHCAHTOA. So is SOH. There's our O and our H that we're looking for. So that means we're going to use, so since it's sine goes with the O and the H, that means we're going to use sine of 7. Okay, so we're going to use the sine of this angle, sine of 7 degrees will equal the opposite side, y, over the hypotenuse, y over 5. Okay, that's the equation that we've set up. All right, now remember what we're trying to do is find y. And so think back to some basic Algebra 1. If you have y divided by 5, how do we undo the dividing? We multiply. So we're going to multiply by 5 over 1 to get this to cross out. We're going to have to do it on this side as well. And so what we have here is 5 times the sine of 7 equals y. This is where you need your calculator. All right, so I'm going to bring my calculator back up here. Here, if you notice right here, here and here, here's your sine, cosine, and tangent buttons. And so what I'm going to do here is I'm just going to type this in to find out what y is. I'm going to type in 5 first of all. Then I'm going to type in the sine button. And then 7, close parentheses, enter. And it tells me 0.609, blah, blah, blah. Oh, you know what? Oh, you know what? There's one thing I forgot to mention, and I don't know if I'm going to check something here. I got going on this really quickly, and I think I have it here, but here's something that I thought was really important that I should probably tell you first of all, and I forgot to go to it. When you're doing this in your calculator, make sure you set your calculator to degree mode. Okay, I think I already have there, but I just thought of that when we were doing that. So let me bring my calculator back up. To get to degree mode, there we go. To get to degree mode, go to your mode button right there, and if you notice, you see all this stuff come up, and here's this third one down, it says radian or degree. You need to make sure it's over in degree mode. So, if it's not already, like just scroll down with these buttons over here. If I hit enter on that, now I'm in radian mode. If you notice, now you can see I'm in radian mode. So you don't want it in radian mode. You have to go down there, go over, scroll over to degree, hit enter. So now you notice that the degree is lit up. Then you can hit just second function and quit to get back out of that. Okay, so anyway, okay, here's where we're at here now. I did this, got 5 times the sine of 7 equals y, and so what we got was that we got y is approximately what, 6.61. You're like, well, that seems a little weird. What does that mean? Now here's the thing that's kind of a little tricky here again. Notice what we were using. We were using feet in our calculation. Okay, we were using feet. So what that means is it means the 0.61, that's in feet, but they asked us to give it in inches. So let me bring my calculator back up here. So if we have that's in inches, or that's in feet, I have to do what? Times 12. And so that means, here, let me write it. So then remember, that's in inches. And so then we have to go times 12 to get y to equal, or sorry, stupid, that's feet. And so I have to go times 12 to get that y is approximately 7.3 inches. So a little tricky because you have to also change the units there. But I think we've got another one. Let's do another one with the trig stuff here. Hopefully that'll be better. Okay. All right, so here's another one. Bottom of a handicap ramp is 15 feet from the entrance of a building. The angle of the ramp is about 4.8 degrees. How high does the ramp rise off the ground to the nearest inch? All right, so how high does the ramp rise? That means this is what we're trying to find over here. So this is going to be like our x over here. Okay, so let's set it up. It's based on this degree right here, which is 4.8. Let's figure out where everything is. What's the hypotenuse? Okay, well, hypotenuse is always straight across from 90, so this is hypotenuse. From 4.8, this 15 is right next to it, so that's adjacent. The x is the opposite. Okay, so what do we know, or what do we have variables for? We know the opposite and the adjacent, right? So think back, what of our ratios, our trig functions, what uses opposite and adjacent? So you got so, ca, toa. Oh, toa is the O and the A. So that means we're going to use the toa part. So the tangent is the opposite over adjacent. So we're going to say the tangent of 4.8 would equal the opposite x over 15. Okay, well, we got to get x by itself. Let's go times 15 over 1 to cancel that. Times 15 here. So we have 15 tangent of 4.8 would equal x. So calculator. So we're going to type this in. We're already in degree mode, so I'm just going to type in 15. This time the tangent button of 4.8. Close parentheses, and we get there that x is about 1.26. But now remember, just like before, it's not going to be like this all the time, but remember before we were using feet. So this is 1.26 feet, but they asked us for inches. So we say if that's how many feet there are, then we just take the 1.26 and divide by 12. Divide by 12. Oops. Sorry. 1.2. I am having problems with this. 1.26 times 12. I just can't seem to get that 2 button right there. There we go. So that means that if it's 1.2 feet, that x would be approximately about 15.1 inches. Well, it said nearest inch. I didn't see that there because so 15, about 15 if you go to the nearest whole inch. Okay. All right, moving on. Go get some cookies, come back. All right, so a couple of more things we have to do to finish up here. The inverse, or the inverse trig ratios are what we have to talk about. Okay, so remember before we did the cosine of 60 degrees, and we figured out that it equaled 1/2 or 0.5. So what the inverse trig ratios do is it just kind of does that backwards, hence inverse, okay? So if we know that we have a cosine ratio of 0.5, then we know it must be a 60-degree angle, okay? So it's just the opposite. Instead of finding the cosine of 60 and finding the the fraction or the decimal like we did, we know, hey, if I have a fraction or decimal, this will take it back to the degrees, okay? So therefore, if we know sine, cosine, or tangent of any acute angle, then we can find the measure of that angle, okay? So this will make more sense in a second here. Again, there's kind of a general whole thing here. First, one of the main things to keep in mind here is this. This notation right here, this sine and then the little -1 up here of x, this is the notation for the inverse sine. Okay, so this is what we say for the inverse sine of x. And so what they're saying here is, if you know that the sine of A is x, then the inverse sine of x would equal the measure of angle A. Likewise for cosine and tangent. Let me explain it a little bit more here as we work one out. Okay, so the main thing to remember here, first of all, is with these inverse trig ratios, the inverse ratios, all right, here, inverse ratios will find the measure of the angles. Okay, so when we do the inverse trig ratios, we're finding the measure of the angles. When we're doing just a regular trig ratio, we're finding the sides. Okay, so that might be something that can help you there too. All right, so let's see what we can do here. So we're doing angle P. So this is the angle that we're looking at. Based on angle P, where's the hypotenuse? Well, first of all, the hypotenuse is always the same. That's going to be over here. All right, from angle P, what's 13? 13 is right next to P, so this is adjacent. This is the opposite side over here. Okay, so what we know, the two sides that we know are adjacent and hypotenuse. Okay, so what trig function are we going to use that gives me adjacent and hypotenuse, the A and the H? Okay, think back, we got what? So, CAH, C-A-H. So that means it's what? Cosine is adjacent over hypotenuse. So we're going to say this, we're going to say the cosine of P would equal adjacent 13 over 19. Okay, well, that's all great and fine, but we're trying to find out what the measure of angle P is. So they said if we take the cosine of that, it'll give us this. So this is kind of what that last slide was trying to say, was if you know the cosine of something is this, then the inverse of this would be P. And so kind of the way I like to think about it is, you know how we've talked about the opposite of multiplying is dividing, the opposite of adding is subtracting, the opposite of taking a square root of something is squaring it. I like to think of it that if you have the cosine of this, then the opposite of that, you know, when we do the opposite, we move it to the other side of the equation. So to move this to the other side of the equation, the opposite is the inverse cosine. So that means when I move this over here to this side, I'm going to make it the inverse cosine. So that means that I'm going to have P would equal the inverse cosine of 13 over 19. Okay, so that's kind of what this inverse trig ratio does. It says if the cosine of P is 13.9, then the inverse cosine of 13 over 19 is P. All right, how do I do this on my calculator? So on my calculator, notice, it's kind of hard for me to see because it's really small, but you might be able to see it better. Right above the sine, cosine, and tangent buttons, there's a little sine -1, cosine -1. That's your inverse functions right above that. So to get to that, you hit the second function, the blue one. And so we want the inverse of cosine. So here's cosine. So we're going to go second function, that cosine button. So that gives us a little cosine -1. Then I'm going to type in 13 divided by 19. I'm going to hit enter, and it's going to say 46.8. So that means P, the angle P, would be about 46.8 degrees. Okay, let's do another one. Okay, so use a calculator to find the measure of angle D. This time angle D. All right, here's angle D. Let's kind of set everything up here. Here's the 90 degrees, look straight across. This is the hypotenuse. So from angle D, what's 16? Is that adjacent or opposite? Well, it's not right next to D. It's way over here, so this is opposite. Okay, so that's the two that we know, the hypotenuse and the opposite. So what sine or what trig function uses opposite and hypotenuse? Think through that. You go, so, oh, SOH. That's the so. So that means, you know, we've got this situation. Sine is opposite over hypotenuse. So that's the sine. So we're going to say, oh, well, the sine of D would equal the opposite, 16, over 23. Okay, now remember, we got to find out what D is. So it's kind of like we got to get D by itself. So I'm trying to move the sine over to this side. How do I do that? Well, that's the inverse sine. So we're going to say that D, or the measure of angle D, would be the inverse sine of 16 over 23. And so we're just going to put that in our calculator. So again, here's the sine. Right above it is the inverse sine. So second function sine, there's our inverse sine of 16 divided by 23, close parentheses, 23, close parentheses there. And then we'd say, oh, that's 44, about 44.1. So D would be about 44.1 degrees. Okay. All right, I think one more thing, and then I'm wrapping it up. Last kind of thing is solving the right triangle. It says round the side measures to the nearest hundredth, and angle measures to the nearest degree. Well, when it says solve this right triangle, you're just going to try to find any missing sides and any missing angles. So kind of whatever's missing, you got to find. We know this is 90. We don't know these two angles, so we got to find those two angles. We know this is 7 and 4, so we're going to have to find side AB as well. You can do this kind of in any order you want to. But let's just start with, let's try to find angle A here. Just randomly pick that one. So if we're going to use angle A, well, we know straight across from this is the hypotenuse. Then angle A right next to it is adjacent. Way over here is opposite. Okay, so what are the two that we know? 4 and 7. That's the opposite and the adjacent. So think through. So, ka, toa. Oh, toa, O-A. We got the toa part here. So that's going to be tangent is opposite over adjacent. So we're going to say the tangent of A would be what? 4 over 7. Okay, well, we want to know what A is. So again, I'm trying to get this tangent over here so that A is by itself. So what does that is the inverse tangent. So A would be the inverse tangent of 4 over 7. Okay, calculator. So this time tangent, here it is, second function tangent. There's our inverse tangent, would be 4 over 7, close parentheses. And so it said to do the angle measures to the nearest degree this time. So this is 29.7, so that's going to be approximately 30 degrees. Okay. So that means this is, okay, stop it. So that's 30 degrees. So we also have to find the other angle here. Well, you say, hey, we've done this before. There are 180 degrees in a triangle. And so if this is 90 and 30, that's 120. Take that away from 180, that means this would be 60. So you're just, you're just doing 180 minus 90. Wow. I don't know what that was. 90 minus 30. And so that gave you 60 degrees, and that was the measure of angle B. All right, so the last thing we got to find, we found the two missing angles. All we have to do is find the hypotenuse here, and you go, it's a right triangle. I could do the Pythagorean theorem to find this, and so we can go, since this is the hypotenuse, remember that's your C, and these are your A and your B, so we can just say 4 squared plus 7 squared would equal C squared. So that's 16 plus 49. And so 16 plus 49 is 65. So this is 65. Opposite of squaring it is square root. So C is the square root of 65. And it said, in this case, it said to do what? The side measurement to the nearest hundredth. So we'll just actually put that in our calculator this time. So second function, not that. Second function of, where is it? There it is, square root 65. 65 is, so that would be like 8.06. Okay, so that would be, this side here would be 8.06. So that would be our three answers. So solving the right triangle, you're just finding all the missing information. All right, well, that was very long. I probably will split this up into 2 videos when I post it, and so you can just watch both of them if you need to see everything. All right, appreciate you being here. Hopefully your head didn't explode and all of that, but I'll see you later, and take care of yourself. Bye.